You see the moon hanging over the street, huge and bright, and you pull out your phone because it feels impossible to waste. Then the photo appears, and the moon has become a tiny white bead. The failure feels personal, but it is really mechanical. Your eye is not taking one global exposure. It is constantly adapting, suppressing glare, borrowing context, and letting the brain finish the picture. The phone has to turn one brutal scene into one file, and that file has rules. So this is not a video about being bad at photography. It is about the hidden negotiation between optics, sensor size, exposure math, zoom software, and AI reconstruction. The moon is just the cleanest place to catch that negotiation failing in public. Part of the disappointment starts before the camera. Near the horizon, the moon feels bigger because your brain compares it with trees, buildings, wires, and the ground. The phone does not inherit that feeling. It only gets the angular disk projected through the lens. The camera does not know the moon looked dramatic behind your neighbor's roof. It sees a bright disk covering a small angle of the sky. Unless the lens magnifies that angle before it reaches the sensor, the moon stays small no matter how huge it felt. Most phone cameras are built to capture rooms, faces, streets, and food on a table. That means wide lenses, tiny modules, and aggressive software help for normal life. The moon is the opposite target. Far away, small in frame, bright, and isolated. The moon is not a dim night object. It is sunlit rock sitting inside a dark sky. Auto exposure sees a mostly black frame with one bright target, then tries to make the whole frame usable. That is how crater detail gets sacrificed into a white coin. The fix is not mystical. You tell the camera to stop trying to brighten the whole night. The exposure gate narrows, the sky drops darker, and the moon stops overflowing the sensor. You lose the dramatic sky, but you gain the actual surface. Night mode is brilliant when the scene is dim and rich with detail. But the moon is not that scene. Long exposure, frame stacking, and brightening can help the dark sky while ruining the bright disk, because the algorithm thinks it is rescuing a night photo. There are two different things called zoom. Optical zoom changes the light before it reaches the sensor. Digital zoom cuts a tiny part of the sensor image and stretches it. One gathers more evidence. The other asks software to make a small answer look large. Even if the phone can expose correctly, the moon punishes tiny motion. A small shake moves the bright disk across sensor squares, and digital zoom multiplies the shake. Stabilization can clamp some of it, but it cannot invent stable evidence that never landed. This is why the boring advice works. Hold the phone steady, reduce exposure, and use real optical reach if you have it. A tripod and telescope are not aesthetic accessories. They change the physical evidence before software has to guess. Modern phone photos are rarely one clean snapshot. The camera captures multiple frames, aligns them, rejects blur, combines exposure ranges, removes noise, sharpens edges, and chooses a version that feels plausible. The image you see is already a small reconstruction. This usually works because normal scenes are full of clues. Walls meet floors. Faces have expected structure. Leaves have textures. Shadows follow surfaces. The software has many anchors. The moon gives almost nothing except a tiny disk people already recognize. The strange thing is that the better the final moon photo looks, the more suspicious it can become. If the camera captured only a few soft pixels, but the file shows crisp craters, the viewer has to ask where the extra detail entered the pipeline. The serious version is not that a phone simply pastes a moon sticker onto the sky. It is more complicated. The camera recognizes a moon-like target, stacks frames, stabilizes the disk, denoises it, and may use learned detail rules to make the result look more moon-like. The moon is uniquely vulnerable to this because it is familiar and predictable. It is one known object, seen from one planet, with a texture map everyone expects. A model does not need to understand your night. It only needs to understand what moon detail usually looks like. That is the boundary modern cameras keep approaching. There is evidence from the lens, and there is probability from the model. Most of the time, they cooperate. The moon makes the cooperation visible because the model can know too much about the subject before the photo is taken. A telescope wins before computation starts. It gathers more light, spreads the moon across more usable image area, and gives the sensor actual structure to record. Bigger optics do not just make the moon prettier, they reduce how much the software has to invent. When people get impressive phone moon photos, there is usually a second optical system involved. The phone is not suddenly becoming a space instrument. It is borrowing a telescope, a binocular, or a long lens, then letting its software clean up evidence that is already stronger. This is the part phone marketing tries to blur. Software is powerful, but it does not repeal physics. A tiny lens, tiny module, and tiny sensor area still limit what evidence arrives. The algorithm can negotiate with that limit, but it cannot make the limit disappear. The honest approach is to make the problem simpler. Shoot when the sky is not pure black. Lock exposure on the moon. Stabilize the phone. Use optical reach if you have it. You are not trying to make the camera smarter. You are giving it a cleaner problem. The goal is not to force the sharpest moon at any cost. The goal is to know what kind of image you made. Did the lens record it? Did the software enhance it, or did the model reconstruct it? Those are different kinds of pictures. A camera used to feel like a light recorder. Now it is a decision system with a lens attached. It decides exposure, chooses frames, rejects motion, smooths noise, sharpens edges, recognizes scenes, and sometimes guesses what the subject should look like. The moon feels controversial because it is obvious. But portraits, night shots, food photos, and high-contrast scenes are already negotiated by software. The difference is that a face or a meal gives the algorithm room to hide. The moon is too simple to hide the machinery. This is the deeper question every phone camera is moving toward. At what point does a photograph become a rendering guided by a photograph? The answer is not always obvious, and that is the point. The camera roll is becoming a negotiation record. The moon is just the cleanest example because the evidence gap is easy to see. But the same bargain appears when a phone brightens a dark face, smooths a noisy meal, replaces a blown-out sky, or makes a concert stage look sharper than the sensor really saw. The useful question is no longer simply, is this photo real? A better question is, which parts were measured, which parts were stabilized, which parts were cleaned, and which parts were inferred because the camera had seen similar scenes before. This does not mean every correction is a lie. Stabilizing shake can protect evidence. Denoising can reveal evidence. Exposure blending can preserve evidence across bright and dark areas. The danger is not correction itself. The danger is when correction quietly becomes invention. The most honest way to describe a modern phone camera is not recorder and not artist. It is a collaborator with rules. Sometimes it rescues what the lens almost captured. Sometimes it guesses what the lens could not capture. The moon shows where those two jobs collide. So when your camera makes the moon look terrible, it is not just failing, it is revealing the whole machine. Your eye, the lens, the sensor, the exposure gate, the zoom crop, and the model all disagreed about what the moon was. The blue-white dot in the sky did not break your phone. It exposed the hidden bargain inside every modern image. How much was seen? How much was corrected? And how much was decided after the light arrived?